So, electromagnetism is one of four fundamental forces of physics. There are two aspects to electromagnetic force. Electrostatic force, which builds up a charge in an object and can travel in the form of an electron stream. And two, magnetic force, which is responsible for how magnetics work. Even though their effects look different to us, they are in fact one and the same. Remember, electromagnetism acts on objects that have an electric charge. This charge creates a field around an object. But a magnetic field is a little bit different from an electrostatic field. For starters, unlike a charged particle, which can be positive or negative, a magnetic field has both a positive and negative field, what we call north and south poles. Magnets always have both poles, no matter how many pieces you cut them into. For example, with my magnets that I've bought at Harbor Freight, and pieces of a computer magnet that was in a hard drive. But magnetic poles react very much like single pole charged particles. The same poles repel each other and opposite poles attract. For example, I've got two magnets here. Two magnets, small round ones. When I bring them together, trying to bring the like poles together, it pushes itself away and wants it to go beside itself. Oh, like that, bringing the negative or the opposite poles together, excuse me. So trying to put like poles together, it doesn't allow me to do it. It's trying to repel them, trying to push it so that the opposite poles will attract themselves. And just like electrostatic force, because they are the same force, magnetic force is carried between objects by photons. To demonstrate that electromagnetism and magnets are effects of the same force, you can create magnetism using electricity. A simple electromagnet is a coil of wires which, when a current is passed through it, it generates a magnetic field. You can make one yourself by passing current through a wire wrapped around a nail or a screw. The screw becomes a magnet, stop the current, and the magnetism stops. The magnets on your fridge are made basically the same way, only with a lot more electricity. Power using special materials to retain the magnetism. So, like this one here, I bought at Harbor Freight, is very much similar to the magnets on your fridge. I have one here. I have one here that I have broken apart. So, for example, they're trying to bring the opposite poles together to make it stick. But if I bring like ones together, it pushes it away, and will always find the opposite poles to attract itself, even though the like ones push it away. Just like the one Harbor Freight, same as you got on your fridge. See? Trying to push it to a certain part of the magnet. Do you know what else is an electromagnet? We are living on it. It's the Earth. So, if an electric current creates a magnetic field, the reverse must also be true. In fact, yes, you can generate an electric current using a changing pattern of magnetism. If you put a coil of wire within a magnetic field and continuously spin the wire of the magnet so that the magnetic field fluctuates, electricity will flow through the wire, which is exciting because this is why we have electricity. Stop moving and the current will stop. This is pretty much how every source of electricity in the world works, from wind turbines to hydroelectric dams to coal or nuclear power, and the only big exception is solar power. And this concludes my presentation.